Simplifying radicals. So we have a list of radicals here, and they're all separated by either an addition or a subtraction sign. And that's what separates terms. So you technically have 4 different terms here. Had these just been multiplication, you could kind of just combine them all. So that's our first indication that things can't be just put together. What we want to do is we want to try to find factors of each of these numbers that actually have, and these are all technically square roots. Radicals can be written anyways. It could be like the cubed root, could be the 5th root of something. All of these are technically square roots. If there's nothing written there, we assume it's the number 2. So we want numbers that have square roots to them. So we might even want to list a bunch of factors and then choose a pairing that kind of is able to simplify. So for instance, 54. 54, you can use the number 2, but then you end up with, I think, 27. Yeah, I think you get 27. So not a good pairing. Can you think of anything that might break down really well?
3 and 6.
3 and 6. Can I find the square root of either of those?
Square root. Yeah, 3.
Well, if we root 3, you're right. We can find the square root of any of these. But when I talk about finding the square root of a value, I'm looking for something like square root of 4 that gives us a whole number. This is going to give us some repeating decimal, which is really hard to work with.
No.
Right?
I meant like it would be like 3 square root 6. Right? Would that equal 54?
Oh, because you took 9 and 6. Okay, so you want to step ahead. Yeah, you're 100% right. That's exactly right. Let's write out what you did, though, just for your notes. You did root 9 by root 6, because 9 times 6 is 54, and then the root of 9 is 3. Perfect. That's exactly what we're talking about. Good. So then for 20, what's another pairing? What's another pair of factors?
2 would work.
2 and what would the other number be?
20. Would it be 10?
Oh,
no, it would be, 2 and 10, yeah.
2 and 10, but neither of those are rootable, or square root.
Oh, no, I mean like 2 and 10. 4.
Yes.
Yeah.
You can just keep taking an extra step.
Yeah.
Let's try to slow it down a little. So 4 and 5, we can find the square root of 4. And we get 2
and
5. Yeah. And we're going to keep the operation in between. Good. I'll keep breaking these up for us. So the next one, you can find the 2 factors of these would be 4 and 6. Yeah. So that ends up at 2 root 6. And then for 80, 8, 10, 42, 4. This one's an interesting one. Okay. So we can do 16.5. I think 16. Is that right?
16 times 5? Yeah. 80.
Yeah. Okay. Now, I was going to break it into 3 right off the bat, but we'll break it into 16 and 5. Okay. And then we can find the square root of 16, and that would give us 4 and 5. Perfect. So now what we have are certain ones that are like terms. And this is where it can become kind of confusing. Technically, my like terms are my root 6 and my root 6. So the negative 2 root 6 and the positive 3 root 6. And the other set of like terms, can I do right green over? Good, I can. Is negative 2 root 5 and positive 4 root 5. If that's confusing, and it might not be, but say that is confusing and the roots are difficult or you don't quite see how they go together, you could always put some let statements. We could always say like let root 6 equal x and let root 5 equal y. And then it's a lot easier to see what are like terms. So when I go to rewrite this, I'd have 3x minus 2y minus 2x plus 4y. Now, we're much more used to working with these types of terms, right?
Yeah.
So this is positive 3 minus 2x. We end up with just positive 1x.
Yeah.
And negative 2y, positive 4y, we end up with positive 2y. And then we can just replace the x and the y. You might not need to do that. You can just write them as radicals. So our final answer would be 1. We replace the x with root 6. So root 6 plus 2 root 5 would be our simplified version of this question.
And do you even have to write the 1 before the root 6?
No, you're 100% right. Because 1 times anything doesn't change anything. Right?
Okay,
So that's it. You're right.
Yep. That's